In this video, you will see how to set up the Pepperl+Fuchs safety controller with integrated expansion port. The expansion port allows safe and non-safe I/O to be connected to the controller and gives it the ability to control a surprisingly large safety system without having to use a PLC. Welcome, my name is Holger Hornes and I'm the Manager of Intelligent Systems at Pepperl+Fuchs. In addition to this video, please check out our other educational how-to videos at the Pepperl+Fuchs YouTube channel. First, I will take care of all the necessary electrical connections and then show you how to use Simon+ configuration software to define the safe and non-safe logic. In today's video, I will be using the safety controller as a standalone mini safety PLC. For this setup, I will be using the following hardware components. The safety controller operating as a mini safety PLC, evaluating all safety devices and also controlling the indicator LEDs on the safety devices and non-safe outputs for machine control. A piece of network cable, a number of modules, this non-safe illuminated push button module. The green button will be used to restart the system after a shutdown, an illuminated EStop switch, and a latching door switch. A 24-volt DC power supply used to power the safety controller, an AS interface power supply used to power all devices connected to the expansion port network. First, we apply 24-volt DC to these intermediate terminals. And from here, power the safety controller via the gray removable terminal. Next, the AS interface power supply is connected to the yellow removable terminals. This power supply offers 2 plus and 2 minus terminals, simplifying the installation as the network cable can be conveniently connected to the second set of terminals. Now we can add modules to the network. How that is done is covered in greater detail in another video. You can find its link in the notes section below. The push button module has been given address 1A. The protective door switch, address 8, and the illuminated EStop, address 9. For this setup, we're going to use the green LED in this tricolor LED cluster to indicate the state of the safe output. The other two LEDs, amber and red, are connected to additional low current signaling outputs, but they're not used at this time. Now that the hardware is all set up, we have to use the Simon+ configuration software to specify the safety logic. We're also going to use Simon+ to set up logic concerning the door interlock switch. After starting the program, we see down here that we currently have no communication. That's because the communication interface is not yet set to USB. So we do that communication setup. We select the USB device. If there are multiple devices connected, we can take whichever one we want from the drop-down box by USB ID. So here it's only one. I've selected it and I start it up. The next step then is to provide a password. This is a new unit, fresh out of stock, and I need to change the default password, which is Simon, all capital. And I need to change it to something different, something I want to be utilizing. All right, having done that, we're going to start a new project. Now I want to warn you right away, there are a couple of things that I will not do initially, and I will wait until the Simon Plus software will come back with warnings or error messages and then correct them. The reason is simply I want you to be aware of these and so that you know what to do when they pop up. The hardware here on the monitor and information window has been auto-detected, so I got nothing to change, but here I still need to put in a title. Standalone system is the title I want in this particular case. I can then go to the bus information tab, and here I need to select which device addresses are on the network. I could simply click off the ones that I have, but what I rather do is I rather use the search button. And the search button comes back and says, should the ASI, the integrated ASI master, be activated? You need to click yes, because only when that integrated master is activated on the standalone system will there be communication with the devices on the remote network. And here they are. 1 is the push button, 8 is the door, and 9 is the EStop. So that's all I'm going to do for now. We're going to come back to the information about monitor and bus a little later, putting in some additional information. On the first processing window, I will take care of controlling the safe output, controlling the motor, let's say. And I do that by putting a safe output device onto the screen. I call this whatever I want, so motor 1 is fine. I'm going to leave this at OSSD1. That's all I have to do in this case. The next thing I'm going to do is I'm going to provide a restart condition, and I want to utilize the green push button module as my restart. So I take a monitor start with a standard slave, and I select the address 1A and the most significant input bit. I want to restart. So this is green button as my restart condition. Then I add the safety devices. I'll start with the door switch, with the emergency shutdown button. So EStop, number 1. And as any mechanical device, I select it as a dependent with filtering. From the address box, I need to select the proper unit. It's number 9. And all these parameters I leave as they are. Next, I add the safety guard switch. So this one I'll call door. And because it's a latching switch, it is configured as a conditionally dependent device. The independent input, or the independent output, I should rather say, is the latching mechanism, and only if it is unlatched can I remove the key. So conditionally dependent is what I have to select, and address is address 8. Okay, so far so good. That's all I need for the safety logic. What I have to do though is I have to control this door switch. I have to be able to open and to close it. So I do that by introducing another configuration window, and on this configuration window I will again put an output. Now this output is a more or less only for a controls purpose, and I call this unlatch. And what I want to accomplish is I want to utilize the red push button module I have, and when I push that button I want to unlatch the door. Now again, this is a power to lock switch, so therefore activating the output here will lock the door, and dropping power from this output will unlock the door. The bit that I have to control is on address 8. That's after all my door switch, and it is the bit 0. So whenever this unlatch output turns on, I will apply power to the door switch, and the key is trapped. I still call it unlatched for a particular reason. Now I'm going to add an automatic restart, and I will add the standard slave that controls this mechanism. So this one is the red button. And the red button is on address 1A, and it's input bit number 2. Because it's a power to unlock, I need to invert the state. That means when I push the button, the unlatch will drop out and I can open the door. When I release the button, the latch will be drawn in and the key will be trapped. So this is all I need to do, and I can now take this and download it. Before I do that, I'll check with a configuration check up here, and I get another error message. And this error message states that I must have at least 5 slaves on the network, which I do not have. I only have 3. So either you add more real slaves, or you go back into information about monitor and bus, select the service diagnostics tab, and provide an address for the safety controller itself. So I'm going to assign address 28 to the safety controller itself. So now I have 4 devices on the network. I need one more, and that's easily accomplished by selecting that I want to simulate 1 additional slave. So now 28 and 29 are addresses that are residing in the safety device, in the safety controller, and I have 3 on the network for a total of 5. Now that we have the safety configuration and the configuration part that takes care of the door switch, we download from the PC to the monitor. A warning message comes up informing us that the hardware we have does not support a certain selected function somewhere in the configuration. That's not a problem, nothing to be done, it's automatically fixed, and by hitting OK, the download keeps going. At this point, we're asked if we want to teach the code sequence. That means if we want to let the safety controller observe the safe data that comes from the individual devices. And we have to do this, so we click yes, and the Sequential Teach screen shows up. What that tells us is here that address number 9, which is the EStop, is in the release state, and in the CT for code table column, we see that the code table has been observed. We have a little less luck over here with the door switch, and the reason is that it's unlocked currently. It's unlocked, therefore it will not go into the release state. So we first have to fix this little issue. The way we do this is we cancel out and we start ACT, ASI Control Tools. We can start this directly out of the Simon Plus software. And what happens next is we'll be warned that outputs may be modified. That's okay. And we get a warning that we're using an unlicensed version. That's okay too. So here are the devices that are currently on this network. So the way to go about controlling the safe output or the output on the door switch is go through the following steps. Bring the mouse over to the triangle symbolizing the master, right click and hit Store Configuration. We're going to now store the display configuration, and that takes all those modules off that are not there, and it accepts those that are in fact present. So now we have the 3 that we actually have on the module plus the 2 that reside inside of the safety device, the safety controller. Next step is double clicking on this triangle and selecting protected mode. That's an important step. If you forget it, you're going to have a little bit of trouble doing this. So you always have to activate the protected mode. Close out and then go to mode number 8. Node number 8 is the door switch. And by double clicking on it, I can select output 0, which latches the door. Perhaps you heard in the background the clicking noise, but what you see immediately is that the 4 bits from the device, the 4 input bits, are now there. So I hit OK and close out of Control Tools. Now I have 2 choices. I can either restart the entire download, which is okay, or I can simply teach the safety data from here on out, getting back into this process of observing the safety code sequences. Because everything is now released, the EStop was released to begin with, the door switch is just released after I pulled in the coil. I'm done with teaching the code sequences, and I can now validate the configuration. For this, the safety plain text log file is loaded, and I need to provide my name and my password to sign off on the validation. Then I can start the protected operation. Takes a second or two. And now we're on the run screen. So what we see here is, if we focus on OSSD1, this is the safe output that would interface with a motor. My EStop is released, my door is latched and therefore also released. All that needs to be done is the green button needs to be pushed and the motor starts up. So if I now hit the EStop, motor 1 stops. If I release the EStop, my green push button again will restart. Exactly what I wanted. Next thing that I have to try and test is if I can control the door switch. So that is done here. Red button will, when I push it, hopefully, drop the power to the solenoid. When the solenoid power drops, the door switch is in the non-release state. So let's see if that works. I push the button, it unlatches the door, and in fact, the door symbolizes here in yellow that it is unlatched. I can now go and pull the key out, and that opens the door. If I put the key back in, and I held the red button all the time, it's not yet latched. I cannot restart the machine. I will now release the red button, which latches the door, and therefore pushing the green button will get everything into run mode. So far, so good. I've accomplished controlling the unlatch. The way to control the LED on the EStop is very similar to controlling the latch on the door switch. We start by creating a new processing window, and onto the processing window we will drop an output. So this one here I will call EStop LED. And the EStop LED is on the EStop itself. So that is address 9, and it's the least significant output bit. And because I want the EStop to be off when the switch is in the release state, but on when the switch is in the safe state, I will activate the inverted bit here. Now I create a copy of the EStop itself. I do a copy and I paste it over onto this sheet and add a start device, an auto start. That's all I have to do. So now I can take this and download it from the PC. After the configuration has been sent, I will be asked if I want to teach the code sequences, which I do not want to do. No need to do that since nothing has changed, no hardware has changed, so I select no, don't do that. But what I will have to do is I will have to go through the validation process as always. So that means my name needs to go here and my password. And then the protected operation can start up. All right, by clicking over on this button, I can tile the windows horizontally, and I want to give them a little bit, change them a little bit. Okay, so here we have our EStop. We've already checked all the other stuff, so the EStop is currently in the release state, and as a consequence, this output is on, but with the inversion in place, the LED, and you just have to believe me that, the LED on the EStop is now off. If on the other hand, I push the EStop in, then this logic turns off, inverting the off state turns on the LED. So now I have direct feedback which EStop I have pushed, and at the same time, through the red push button and this set of logic functions, I can control the door latch, open my door, put it back in, relatch it. If I release the EStop, the LED turns off, and I'm now ready to reset. Let's just take a look how this works on the real hardware. Starting in a state where the EStop is pressed, we see that the red illumination is on. Releasing the EStop turns off the illumination, and pushing the reset button starts the safe output. Currently, the door is latched and the key cannot be removed. Pressing the red push button module unlocks the key, allows the door to be opened, and turns off the safe output. Releasing the red push button, reinserting the key, and pressing the green reset start button turns on the safe output again. I hope this simple example shows you how easy it is to control both safe and non-safe aspects of a machine. Today I used only one safe output, evaluated 2 safe inputs and 2 non-safe conventional inputs, and then controlled 2 conventional non-safe outputs. Certainly much more complicated systems can also be controlled.